Okay, everybody just got a pop-up for that. Well, in 1996, we got a regulation that required us to actually check for maximum permissible exposure for stations. As part of that regulation, there was a set of exemptions from evaluation that was based on the frequency band and the power that you were running. Those exemptions no longer apply as of last year. So that means all of us need to do an evaluation of our station so that if the FCC asks, you can just show it to them. It's not a big deal. I'll show you the evaluation for mine here in a minute. Each time you upgrade or renew your license on that 605, you have this little statement. I have read and will comply with the commission rules regarding the radio frequency radiation safety. Okay, so that's what this is about. This entire talk is about that. Is that my phone? Not anymore. All right. There are two primary things that you need to know about with the regulation. There are two levels of RF exposure that the regulations deal with. One of them is called uncontrolled exposure, and the other is called controlled exposure. Uncontrolled exposures is like any place that the general public could be exposed and not know about it. So outside your yard might be an example of an uncontrolled exposure place. And the controlled exposure applies generally to us as hams in our own houses, vehicles, things like this. Things where we daggum know we're transmitting, and thus, though we can take mitigation if we exceed the regulation. So exposure to members of your household is evaluated with these limits also, because we figure you talk to your wife or husband or friend that's visiting if you're transmitting. So here's your diagram for those RF environments. Controlled environment is like inside your fence line. Uncontrolled environment is outside of it. There is no assumed compliance. This got removed from regulation last year. So you do have to do your evaluation. This became effective in May of last year. I think I wrote something for the newsletter at that point. But you can apply the ideas and learnings from this slide deck to do that evaluation really easily, and you'll be fine. What didn't change is the maximum permitted exposure. And you'll notice that they talk about electric field strength, magnetic field strength, power density. Generally for us, we use power density, milliwatts per square centimeter. And then we have these frequency bands. Now they did, as far as the regulation, extend this down quite a bit further, but it's effectively the same number. So there wasn't anything that. So I'm going to show you a graph of this in a second. This is something you can just look up. Don't try to memorize this. But this is what it looks like when you try to compare the difference between controlled and uncontrolled. These are in the levels. So you're going to notice a couple of things. The most stringent MPE is that where there is a lot more coupling of the frequency wavelength into the human body. So since a lot of people are around 2 meters tall, that means the 2 meter band is the one that has the most stringent regulation because it couples more into you, full body coupling of the RF. Now we get into the math. So let me talk a little bit about it. When you have a radio wave, what you have is a spherical wavefront that goes from the antenna outward. Okay, spherical all the way around the antenna and outward. So what this equation is taking into account that spherical structure of that wave in computing the power density. So that's all it is. That's what the 4 pi r squared is the accounting for the spherical nature of it. P is your power input to the antenna, and you know what that is, 100 watts, whatever it is. The G is the gain factor, which is a numeric value of the antenna you're using. So, and the distance is like I said, distance from the antenna to wherever you're trying to go. So this is pretty straightforward. Now, I told you, gotta be careful of the units. Everything that I have here is milliwatts per centimeter squared, milliwatts, numerical gain, which has no units, and centimeters. So you can choose another unit set, use the same equation. You could use feet if you wanted to. But you need to be consistent with this or you'll get junk answers like there's no tomorrow. It's really easy to get junk. So let's go through some notes on the gain. Your power input to the antenna times the gain is sometimes called the effective isotropic radiated power of an antenna. You may have seen that term. Well, that's basically what it is. It's just, if you're familiar with that, other than that, just forget it. The gain is 10. If you have a gain in dBi, which most antennas are given out in, the numerical gain is 10 to the dBi divided by 10. So a 7 dBi antenna has a G of 5, 14 dBi antenna has a G of 25. Sometimes you see that spec'd on dipole, gain over a dipole in your antenna. So I have some examples of these here in a minute. So depending on what you have, information you have about the antenna you're using, you may get it in dBd, and then you can convert that to the other form here. You want to be consistent though. If you're using dBi, use dBi. And convert the dBd to dBi like this shows. Okay, another interesting problem you run into is ground reflections. So you know that your antenna at home is not over a perfect ground. It's just not. It's not like out over seawater or, you know, purely reflecting surface. So, but you can either model that directly in an antenna modeling program, or you can just do what they did here, which is the EPA said that the ground reflection will increase the field strength by a 1.6 times. And that leads to 2.56 times the power density increase. So you could use this equation to compute that. And I recommend this, by the way. I do recommend using, ground reflections in your calculations. It's easy to do. Now, when I do field day, I do a 1.0, so 100% ground reflection, because we don't know what we've got really well enough at the field day site to know what to put in anyway. Okay, so what about the distance to the antenna? What I use is any distance to a piece of the antenna. The shortest distance to a piece of the antenna is what you want to use for that. So if you're evaluating people on the ground or people in the house or whatever, you can make this assessment. The other thing to do is to deal with the actual towers that you might have. And you can compute the D via Pythagorean theorem is the easiest way of converting it. And so there is a height, and you can get the D directly. So that's how you get the distance. So this is an example of it. Dipole, 35 foot above ground. Point of it is 125 foot from the center of the dipole. Distance above ground level, at ground level, is 129.8 feet. Distance at human level, you strike 6 foot from that, and it's 128 foot. So you're a little closer to it because you're higher off the ground. So just use something like this to help you arrive at your distance from the antenna. All right, I updated this a little bit to reflect the duty factor. Generally speaking, there is a duty factor in the RF that you're transmitting based on the mode that you're using. If you're using FM, it's 100% duty cycle, because it's always on, even if you're not talking. If you're using single sideband and you're not using a speech compressor, it's about 20% your power. If you're using a speech compressor, it might be 50%. For digital modes, there are a couple of different digital modes here that I updated for, since FT8 and FT4 are real common. I run those at my station all the time. So I definitely know, what's happening with that. I see what happened. I don't know why that did that, but I can tell I'm still on. Okay, so if you use this for duty factor, you can. So if you had, say, 100 watts and you're on single sideband normally, well, that's really 20 watts from the standpoint of computing the power density. Okay. So duty factor times power input to the antenna. And so that makes it easy. So let's do some examples. You're running a full legal limit. SSB is 300 watts. Speech processing 750. CW is 600. LDET 1500. And that's what you use for your power input to the antenna. 100 watts PEP. Digital modes, most digitals, 100 watts. FT4, FT8 is 50 watts because it listens as much as it transmits. So that's why it's 50%. FM, 100 watts. Okay, now we're gonna see how to put this all together in a minute because I have a spreadsheet that will show you for the various antennas. But let's say that you have antennas of a certain type, and you're able to get from the manufacturer the performance numbers for that antenna. So this is for a Force 12 4-element 20-meter Yagi. And you might be able to read that they give you all types of information and gain at 74 feet, which is sort of interesting. Net gain 6.6 dB. So the gain that they specify here gives a ground reflection average ground at specified distance, 74 feet. I wouldn't use this. I wouldn't use that number. That's a BS number, in my opinion. All right, for net gain is the isotropic gain over a standard dipole. So this is notice that this number here is 6.6 dBd. So we got to convert that by using that other equation I showed you. And this is showing that the numerical gain for this antenna is 7.5. So a lot of times these manufacturers will give you junk in the specs. So you got to spend a little time on them. All right, now here's one of my antennas that I use. It's a 12-element log, and they give various gain. But a couple of these are really fictitious. I mean, they're done very, very strangely. They don't tell you how it's calculated, although you can see that converted 8.64 dBi. These two are related. This guy at 1 lambda, that's what type of reflection did they use? I have no idea. So this isn't really useful for us. In reality, this particular type of antenna runs 5 elements on 10 meters. They're active, 4 active on the rest of the bands. So you really almost have to simulate this to do it, to really get a real good understanding. So I use something a little, closer to the guidance in the OET book for 5 and 4 element Yagis when I do the evaluation of this antenna. So you don't have to really simulate. And let me tell you, simulating log periodic is not easy. It's just not easy to do correctly. But anyway, the gain is 8.6 on this antenna. Here we go. Some of you have steppers. These are 4-element Yagis, but Steffer gave you the actual real radiation numbers because they measured them in an antenna range. So you can use their numbers. So notice this is a lot more than my 12-element log periodic gain. It's a better antenna from that standpoint. All right, TH7DX occasionally shows up at field day. I don't remember who owns this. There is no manufacturer definitions for this. This is an easy beam to simulate, and thus you can and produce a gain number that you need for the equation from it. Okay, now let me see where I can get us another screen sharing opportunity. Did someone write me a chat? No. Okay. All righty. So I need, maybe I don't have it up. And so let's close this. I don't care about that. Okay, so I'm going to bring this up and share it full screen as soon as I get back over here and do it so everybody can see it. It's a Zoom bug. Here we go. Okay, I'm going to bring this up bigger. You guys should see that. I'm going to shrink this out of the way. And I'm going to make this larger. Where is it? Zoom. I want zoom at 200%. All right, so let's apply all that stuff that we just went through that you're not going to remember. Let's just show that. Let's just show how it applies. All right, I have an antenna that's for the 10-meter band. I'm running 100 watts. By the way, these are field day stuff. I'm on 50% duty cycle. I am 10 foot, I'm standing below the antenna. It's 10 foot above me. It's a 2-element antenna, 4.5 dBi. And I'm averaging, I'll talk about time averaging in a minute. But this thing, these are the numbers you input. And the spreadsheet calculated the limits. All right, so you're going to notice that for uncontrolled, this particular antenna, because 10 meters is a tricky band, because it's also, it's not quite as bad as 2 meters, but it is the worst of the HF bands as far as limits. So you see, in an uncontrolled situation, if you had someone not knowing that you're transmitting someplace, say that your antenna is close to the sidewalk on the street and someone is going by, that's uncontrolled. And they're getting exposed more than the regulation would let you do. Whereas if they were standing in your yard, they easily meet the regulations. So this is for us and this is for them. All right, so let's look at a couple more stations here. Which stations are these? I should 15-meter phone. All right, so this is up on the bluff, 15-meter phone. 50% Zoom is using speech processing. The antenna on the tower trailer and the actual beam is about 17 feet above ground. Been to field day, you've seen that. This is a 4-element Yagi. So it's 8 dBi. And the time averaging is 1:1, which we'll talk about in a minute. All right, you'll notice I'm green here, so I didn't exceed anything. So you could be walking right there by the antenna and you meet the regulations. We don't worry about this too much. So you definitely have to have your scenario down. Now here is 20-meter phone, 30 foot up. That antenna is 30 foot above the ground level at the top of the bunker. 8 dBi, 4 element. And this guy is very minimal percentage into the regulation. So you could be there all day and it would be just not a problem.
But we knew about this on field day, and the GOTA station is 134 feet. I'm not sure the tent's 134 feet from the antenna.
Right. I don't know what I have GOTA in this. I might have GOTA from 2019.
Well, it was be 10. Well, no, it wasn't necessarily 10 meters.
Here we go.
No.
No, they shouldn't have been on 10 meters. They should have been on
Right.
20.
Yeah, they were.
All right, here's GOTA.
Right.
Here's GOTA from 2019. Again on phone, 20 foot away from the antenna that year, which was about right. It's a 4 element antenna they had up, so that was 8 dBi. And still fine, you know, from a safety standpoint.
Yeah, GOTA used to be 10 meters, but no longer.
Yeah, no, GOTA shouldn't be on 10 meters ever now. You don't want them in a dead band, you want them getting cues. We have, this is for Dean's 40 meter setup with those east-west beam, wire beam, and north-south wire beam. All right, so here's the east-west wire beam. This is like 7 elements or 6 elements, so it's 11 dBi. And it's about 15 foot above your head, or up, you know, the way it's up there. And we see that there isn't much happening there. Again, 16%. All right, for the other one, again, it's about the same height, but it's only 4 elements. That's north-south. And he's not transmitting on both of these antennas at the same time. Or we'd have to sum these two up. Okay, for VHF, the antennas are stacked. 6 meters is at the bottom, then 2 meters, and then 440, 70 centimeters. It's the way it's stacked on the tower. The gains of these are really nice antennas. They're, I think, 18 elements on one of these, so 17 dBi on 2 meters. This one's 6 elements, I think, 5 or 6, 9 dBi. And then the 430 is 20 elements or something. It's pretty good. And you see that for uncontrolled already, you can tell that we have a little interesting problem here. That one, because it's in the field day site, we treat this as all controlled exposure. So what I have to do to make this a mitigation work, I'll just tell you. Some years, I actually put a barrier tape around the bottom of the VHF antenna tower and say, stay out of that area. Now, if you look at this particular numbers, you don't really notice why I do that. They're not transmitting on all of those bands all the time. Because they're using usually one rig So they're switching between the various antennas. So only one of these really applies. Well, the problem is you have a whole bunch of other antennas that are close to that VHF tower, 20 meters, 10 meters, 15 meters, are all relatively close, within, say, 50 feet of that tower. So you have to calculate what the value is at the VHF tower from all of those other sources around it, and then sum up the percentages from all of those other sources and from this tower's percentage. If that percentage is less than 100%, you're good to go. If it's more than 100%, you have to do some mitigation. And in my case, the mitigation is to put some caution tape up to keep you from standing under that tower for a long period of time. Don't put a picnic table there, right? Don't do that, okay? That's another reason why the picnic table is out really far away, out in the center of the bluff there. It avoids all that issue. Okay, how are you guys doing on this? You want to see my house stuff? All right, so I'm going to show you, this is all my setup. AG7T, AG7T digital. Now, because the 10-meter band is the absolute worst, I choose to evaluate myself at 10 meters, even though I'm hardly ever on 10 meters. But I evaluate the station at 10 meters because it's the worst. 1,300 watts out into the antenna. 0.4 of, 40%. 50 foot is where that antenna is up. It's 11.8 gain because it's 5 elements on this band. All right, so we're going to see that for uncontrolled, I'm over the top, but for controlled, I'm fine. But it's pretty high. This is high power being used on this. Okay, notice that for digital on that 10-meter band, I'm higher because the duty factor is higher for that. Okay, so I'm looking at, for my 40 meters, a different beam. So for 40 meters, it's nothing. Now this is a 2-element 40-meter beam at 60 feet up. And depending on whether I'm doing digital or phone or CW is what this is for. So I do a lot of CW. I don't do much phone. But you can see my percentages are really nothing. And then when you get to 80 meters with this setup, this isn't quite strictly correct for me, but it's close. I have a 80-meter antenna that goes up to the top of the tower and slopes down to 30 feet. Okay. So I could probably change this to say 30 feet. And we'll see what that did to the very small percentages for 80 meters. On 80 meters, you can almost grab the antenna before you exceed the MPE for this. Okay, and let's go down to this one. What is this? Oh, all right. I have a situation where If I'm pointing, say, over the North Pole into Europe or something northeast, the beam, the RF from the beam, the pattern, will be in my neighbor's bedroom. So I didn't like that. I said, I got to know whether I'm causing them trouble from our safety concept. So that's what this line is. This is, I'm 200 foot away. The antenna is 200 foot away from their bedroom. So this is the same setup, 5 elements. And the neighbors, 23% of the maximum permitted. So that's good. I felt good about this. So I did this just as an experiment to put my mind at ease about what I was doing to my next door neighbors. The other direction, it's like 400 feet to that neighbor, so I wasn't too worried about it. Okay, any questions from Zoom?
What about HT?
I'm about ready to flip down one line. Okay, now, because back before last year, the regulations allowed us to not have to evaluate RF safety when the transmitted power on 2 meters was less than 50 watts. So that meant the HTs that we had, we didn't have to evaluate. But now we do. And I'm going to show you the evaluation of that using these far field equations, which are invalid. I will say invalid for these HTs mostly. Although Al may have more feet away from his antenna than I do here. All right, so I'm running on 2 meters. You guys see that all right? Let me move it up. All right, I'm running 5 watts. This is FM, so it's 100%. I am 6 inches away from the HT when I hold it out like this and I'm talking. My gain, I'm saying is 1, so I'm treating it as if it was a vertical, quarter wavelength vertical on that helix antenna. You might get different values for this, but I'm comfortable with this. And then my duty cycle is, I haven't covered this yet, but let me talk about it a little bit in relationship to controlled and uncontrolled. When you have a duty cycle for uncontrolled, the averaging time is 30 minutes. So what I was doing on this is on key down for 30 minutes for uncontrolled. And for controlled, the averaging time is 6 minutes. So this one that I use means that I'm key down for 6 minutes for the controlled environments. So I wanted to evaluate this. This is clearly a controlled environment. I am using the HT myself. I know I'm using the HT because I poke the button, right? To key it up, hook the PTT. So I'm going to evaluate this is I'm talking over a 6-minute period how much of the time. I could do a quarter like I did here. Is that about right? Am I listening 3/4 and talking a quarter? Or am I a big talker and I'm doing 50%? of the time. 3 minutes out of 6, I'm talking, and 3 minutes I'm listening. Or is it something else? This is why having timeouts on your repeater is a good thing, to try to remind you to not transmit long amount of time with your HT. I don't think it really helps. People are going to talk anyway. But anyway, the other thing to do on this would be to change this to talk for 1 minute out of 6, which is about like me. I'm probably going to talk 1 and listen 5. Okay. So let's see what happened over here. Well, by doing that, I do meet the RF exposure limit. Okay, for this. Now, but if I increase this to being back to 0.25, so talking 1.5 and listening for 3.5 or something, you see that I just blew the regulation. I've become unable to meet the maximum exposure for an HT. Now, this particular evaluation is bad, in my opinion. It's bad because it's using a far field analogy to look at a near field situation. If you bring that HT right up to you, that's definitely in the near field. And so this is sort of BS. It's not a very good evaluation. So what we need to do is have a methodology that looks at the near field. The OET bulletin does have near field exposure information in it. And I have another thing to hand around, which you guys need to see. You can get this on the web, just like the OET bulletin. What that is this is the guidance given for mobile and portable stations based on the change in the regulation. So there's 2 ways of getting evaluated in this. One of them is specific absorption of RF. And this is what cell phones are evaluated at. They take a head full of a certain liquid. They measure the temperature of that liquid. They key the cell phone up there and run it for some amount of time and measure the temperature again. And that is used to calculate this SAR for that. The other way is use maximum permissible exposure limits. And that applies to us because in this 2-meter HT case, it covers the entire spectrum. The other way of doing it only goes from 300 megahertz up. So it doesn't help us at 2-meter evaluation. Even if we weren't, I mean, I don't think we're going to buy one of these really expensive heads and do all that. We're not doing that. So the MPE way of doing it is the way that I recommend we do it. And I'm sorry I couldn't get that done in time to show you how to do it, but I'll get to it and I'll reissue this information when I do it so that you can do it also. Generally, you don't need too many of these. You have 2 things. Who brought their long antenna HT with them today? Right? Okay. What size is that antenna and how much gain does it have? Well, it's about 13 inches maybe. All right, it should be, if it's 2 meters, it should be 19 inches or 18 inches or so. Well, I don't know. But I don't know what the gain is. Yeah, exactly. Yeah, so see, so you'll look up your manufacturer's gain for this antenna, and you're going to use that, whatever it is, you know, in your computation. Now, the um, the length of this antenna does factor into some of the equations because they want you to do 2d squared over lambda, okay, where d squared is the longest length of the antenna for these near field calculations. And so the lambda is 2 meters, and the length of this is about an eighth of or a quarter to an eighth of wavelength. Okay, so you can probably just compute this all in wavelengths and get it solved. Go ahead.
How many wavelengths is the near field within it?
Okay, it turns out that he asked how many wavelengths is near field? Well, it's not really that. Okay, the way it's computed is really simple. I explained to you that you have that spherical RF thing going out. Okay. If you're far enough away, that RF, the edge of the sphere looks perpendicular to where you are. Okay. If you're closer in, then you have multi-path from that antenna. You have from the center of the antenna and you have from the edges of the antenna. When that gets beyond 12 degrees or 20 degrees or 12 degrees, that defines where the field, near field and far field transition happens. So it's definitely computable for that. For 2 meter HT, I think it's 6 to 8 inches. So it's not really ridiculous on that, but you can compute where that is. Basically lambda over 16 is a good number to remember. So 1/16 of a wavelength, somewhere in that area. So I didn't say really the right thing because I think it is that, but this is all in one of these documents that's coming around.
I was just going to say Nagoya is 16-inch. On Amazon says it's 2.5
dBi?
dBi.
Yeah, great. So we could use that. All right, so we could make, so let's just enter this into here and let's see what happens. So 2.5 dBi. I'm still 6 inches away. I'm going to go back to 1 and 6. All right, so I'm red here already. So right off the bat, we see that we use that and we're sort of blowing it from the regulation standpoint from the traditional way they tell us to calculate. So strictly speaking, this says don't use your HT, for very long. Just don't do it. But in reality, we know from 20 years of this regulation that these HT power levels at 5 watts have not been a problem from an RF safety standpoint for anyone. So this is way too conservative for that, and I think we should use that second document that I sent around and evaluate it. But my recommendation is evaluate your HF 10 meters, 2 meter tower, 440 tower stuff. Forget about your HT evaluation for right now until there's more guidance from the ARRL or someone computes something that is of useful to you. For mobile rigs, Used to be, you get 70-watt mobile rig, you do an evaluation. So the evaluation was done from the antenna that's on your bumper to a passenger in the front seat usually. So that's like 7 foot away, 7 or 8 foot away, and 50 or 70 watts. So let's go look at one of those with this. We're going to run, say, 50 watts. And the gain of that antenna might be 3.5. The distance is 6 feet, about. And I'm talking for 1 and listening for 5. All right, so easily I'm fine with this in the car. Just adding that little bit of distance, even though you had a lot more power, is not a problem for this.
Depending upon where the antenna is mounted, does it make a difference if you've got, say, it's on the roof?
Yeah, it makes a lot of difference. It depends on where your roof is metal or not. If it's metal, it shields you from the RF, so it'll be less than this. It might be closer.
Yeah.
But again, if you're feet away instead of inches away, it's going to look pretty good. So like, even if I doubled this, so we're guaranteed to be in the far field here. Let's make it 3 feet. I'm still good because I'm still green over here on the right. How about 2 feet? All right, 2 feet. I did blow through it at this power level. Yeah. Actually, this existing spreadsheet has been available online on the club site in the zip file for the previous presentation, and it will be available again in the zip file for this presentation we put up, because the previous presentation tells you you're exempt from having to evaluate. You're not. So you're going to get a different slide deck. Okay, I need to go and finish. I got about a minute. I don't know where I can make it in a minute. Let's try it. I need to stop sharing and reshare. Am I able to go for just a little bit more? All right, I'm going to do this. We want to do time averaging. This is hard to read. Okay, but basically it says is the RF output and the exposure time, and is equal to the limit value times the averaging time. So you saw I did an averaging time of 1 in and 5 listening, 1 transmitting, 5 listening. That's what's doing this. This is, so if you don't transmit during a 6-minute period, there's no exposure, of course. In the uncontrolled case, you have to not transmit for 30 minutes, or there's some exposure. So you can use this to average that, and the spreadsheet does this. All right, how to use time averaging. You can set these two the same, which is the way that I did it for the field day evaluations. So let's do the more limit. So 1500 PEP, no speech processing, 2 minute on, 2 minute off, then repeat. Controlled exposure, 6-minute averaging. 1500 times 0.2 duty factor, right? 2 on, 2 off. Time of 0.2, I guess 0.2 is the SSB non speech process duty factor. Then you go by the averaging factor, which is 4 minutes. You're transmitting for 4 minutes out of the 6. And that gives you 200 watts to use for your power. Uncontrolled, still 30-minute averaging. So you're doing 1500 and you're doing 4 minutes. I'm sorry, 2 minutes on, 2 minutes off. So how many 2 minutes ons are there in 30 minutes? All right, 20 minutes. 20 minutes out of 30. So it gives you the same power value to use. So in this case, it didn't make any difference. But this is based on how you operate. So you have to be aware of what you're doing for that. I told you that if you have a multi-antenna situation where there are multiple transmitters, I should say, multiple transmitter situation, you have to sum all of the percentages at the point of interest from each of the transmitting antennas. You sum the percentage, not the field strength value, the percentage of MP. As long as that's less than 100, you have no problems. We never have problems at field day, except for, I'm going to show you in a second, a problem we had in 2019. But generally, we don't have the problem. I have this big thing, this calculation engine that grids the entire field day site and computes all for every grid point, all the antenna contribution to that grid point. And then I light it up red if it's greater than 100%. And so we know where we have to put the caution tape. No. I take the same equations you see here, like you saw all those antennas that are at the field day site. I treat those as all transmitting at the same time. And then I sum it based on the distance to the grid point that I am from each of those antennas, because I have a GPS coordinate for every one of those antennas. So I know where they are. Yeah.
So does that take into account verticality as well? Does that take vertical distance into account? Because the antennas are different heights.
Yes, that's exactly correct. I apply Pythagorean's theorem, like you saw in the deck, to compute the point on the ground. So I get the distance from the height of the antenna above ground. So yes, good question on that one. All right, so this is CW Beach. This is the only violation we had in 2019. And I hand drew the picture so that you can see it. Real close to the 15-meter vertically oriented Yagi antenna, they stuck a picnic table for lunch and a canopy over it. So there are people going to be sitting there eating lunch at that picnic table. For controlled exposure, it was exceeding that. So my recommendation to Mike, this is CWB, so my recommendation to Mike was either move the darn table or don't transmit on 15 meters when people are having lunch. Both of those mitigations work fine. But that was a hot spot that was identified by my gridding. Okay, that's it for me. Questions from Zoom?
ARRL has a calculator, and I just did the HT calculation, and they complied or matched up with what you were saying, Scott.
Yeah, it's identically the same.
6 inches from your face for a handheld, and that little antenna is much closer than 6 inches.
Yep.
I don't know what we can do about
Oh, we just have to use that other document and compute this stuff. That's what
that.
we have to do.
But
Because
radiation,
we know that this is not an RF safety issue for most HT usage in ham radio. Just
that's true.
not a problem. We have decades of information on this.
Is this why, it's my understanding that I assume the FCC is the one, does not allow a handheld radio to exceed 5 watts?
No, you can
Because
get 7
if you're
watt.
running a handheld
You can
with
get
50 watts,
7-watt handhelds. So there isn't that specific regulation. I mean, I have a ICOM handheld that's 7 watts.
really?
Okay.
Okay.
Now I turn it down mainly to 1 or 2
But it was
watts.
manufactured before the rule.
Oh, maybe. Okay. Any other questions from the room?